Hi, this is Mrs. Doris with Lesson 2-1, Solving One-Step Equations. Our objective in this lesson is that you will be able to solve one-step equations. The reason that we are doing this is equations can be used to solve many real-life problems in many different fields. We have several vocabulary terms that you will be putting in your vocabulary during this chapter rather than in your notes, but we are going to talk about them and we'll be using them throughout this lesson. The addition, subtraction, multiplication, and division properties of equality basically all say that you can perform any one of those four operations to both sides of an equation and you will end up with equivalent equations, meaning that you have not changed the value of the original equation. We're going to start by solving a couple of problems where we're going to use subtraction. And we'll be using the subtraction property of equality to solve both of these. In the first equation, y plus 2 equals negative 6. What we want to do is isolate the y, and that means we want to get the y by itself on one side of the equal sign. So what we notice is that we have a plus 2 that is attached to the y, and that's what we're going to have to remove. So to undo addition, we're going to use the inverse operation, which would be subtraction. And so on each side of the equal sign, we're going to subtract 2. Now, some of you may have seen in the past your teachers draw a line down where the equal sign goes to demonstrate the two sides of an equation. This is fine if you wish to do that. I will do that on this first problem, but then after this I probably will not. But be aware that's something that you can do to keep the two sides straight. All right, plus 2 minus 2 is 0, so we can cancel that out. Y plus 0 is simply y. On the right side, we have negative 6 minus 2, which would be negative 8. One should always check your work on an equation, and then you know that you have the correct answer. To check it, you want to replace the value for y, negative 8, in the original equation. So in our equation, y plus 2 equals negative 6, we're going to replace the y with negative 8. Add 2 and see if we get negative 6. Well, negative 8 plus 2 is negative 6. And since negative 6 is equal to negative 6, we have a correct answer. It checks out. In our next problem, x minus negative 17 equals 30. We're going to use the rule for subtraction that we learned in Chapter 1, which is to always add the opposite. So I'm going to rewrite this equation now. X plus 17 equals 30. And I highly recommend that you do rewrite an equation such as x minus negative 17 as x and then add the opposite, so x plus 17, because then it's very clear what you need to do to solve it. Again, we're isolating the x, so I want to get rid of 17, and I'm going to subtract 17 from both sides. Plus 17 minus 17 is 0, so I bring my x down on the left side, and on the right side I have 30 minus 17, which would be 13. To check, you want to replace 13 for the x in the original equation and make sure that you get 30. I recommend using a calculator to check yourself. and this way that you know that you have a correct answer. All right, if you have any questions, please jot those down and then bring them to class. All right, in problem 2, we're going to be solving equations using addition. In our first equation, m minus 8 equals negative 14. I'm going to demonstrate a different method of solving equations than we used on the previous two. On the previous two equations, I'm going to go back to those. I call the method that we use the vertical method because we are adding or subtracting, in this case right here, vertically. We put it right underneath each side. The method I'm going to demonstrate on this one is called the horizontal method. On the horizontal method, when you copy down your equation like this, you have to do it again. And horizontal means that we're going to undo the subtraction by adding the 8 to both sides. The horizontal method looks like this, where you're not adding vertically, but you add or subtract or whatever you are doing in a horizontal fashion. This is not my preferred method, but it's a very good way of doing it. It requires maybe a little bit more writing than you have to do otherwise. All right, negative 8 plus 8 is equal to 0, so I'll bring down my m. And negative 14 plus 8 is negative 6 for our answer. Checking our work, we would take negative 6 minus 8 and make sure that we get negative 14. In our next equation, we have 1/2 equals y minus 3/2. I'm going to go back to my vertical method, especially since I'm going to be short on space here. And again, I want to isolate y, so I'm going to undo subtraction by adding 3/2 to both sides. Minus 3/2 plus 3/2 is 0. So y minus 0 is simply y. And on the left-hand side, 1/2 plus 3/2 is 4/2, which we can also write as 2. Y is equal to 2. And then checking it out, 1/2 is equal to 2 minus 3/2, and make sure that you get the answer 1/2. In our next problem, which this one is not in your notes, but you might want to add it. I wanted to show this one because here we are adding a negative number to our variable. This is one that you can rewrite if you wish. Adding a negative 21 is simply the same as n minus 21. Writing it this way makes it very clear that our inverse operation would be to add 21. However, when you look at the original equation and you see that what we have to get rid of is a negative 21, the best way to get rid of a negative is to add its opposite. So you can work with this equation and simply add 21 to it. I'm going to go ahead and show that I'm adding 21 to both sides. Minus 21 plus 21 is 0. So I'm left with n equals 15 plus 21 would be 36 for my answer. Showing my check, I would take 36 plus negative 21, always going back to the original equation, and check to make sure that you get 15. Problem 3. In problem 3, we're going to solve two equations using division. Now, what you notice is that you have 15 times x. And while there is no multiplication symbol in there, it's not required, we are multiplying. What we want to do is get rid of the coefficient 15. So that means we have to divide by 15. And if we divide the right side by 15, we must divide the left side by 15. 15 divided by 15 is 1. And 1 times x is simply x. 10 divided by 15 can be simplified, dividing numerator and denominator both by 5 to 2/3. And then to check, going back to our original equation and replacing the x with 2/3, we can check our answer to make sure 15 times 2/3 gives us 10. And it does. 15 times 2 is 30, divided by 3 is 10. In our second problem, our variable is the z. So we want to remove the coefficient -3 and 2/10, which is being multiplied, times the z. So to undo multiplication, we're going to divide by -3.2, and we have to do the same thing to the right side of the equation. -3.2 divided by -3.2 is 1, and 1 times z is z. On the other side, 14 divided by -3.2. This is a place where I would use a calculator to help you with it. We're concerned at this point with solving an equation, and so operations such as this I would not spend a lot of time at, but I would use my calculator to solve it. And you should get -4.375. Once again, check your answer. We're going to check it by taking our original equation, -3 and 2/10, times z, which is -4 and 375 thousandths, to make sure that we get 14. All right, and another great thing to use your calculator for is to check it. Problem 4. We're going to use the final property of equality, the multiplication property of equality, to solve these two equations. What we notice here is that the variable is being divided by 3. So to undo that, we're going to multiply each side by 3. 3 divided by 3 is 1, and 1 times r is simply r. 3 times 19 is 57, which would be our answer. Checking it out, we want to make sure that when we take 57 and divide it by 3, we do get 19. All right, on our second problem, once again, our variable x is being divided by -9, so we're going to undo that by multiplying by -9. And if we do it to the left side, we must do it to the right side to maintain equivalent equations. All right, -9 divided by -9 is 1. 1 times x is x. And on the right-hand side, 8 times -9 is -72. All right, and then be sure to check. -72 divided by -9 is equal to 8. Problem 5, we're going to solve equations using reciprocals. Now the first thing that you might expect to do on this problem, 12 equals 3/4 times x, is to use the inverse operation and divide both sides by 3/4. Technically, you would be correct. However, dividing by a fraction, our rule for dividing by a fraction is to multiply by the reciprocal. So we're going to skip the step of division and go right to multiplying by the reciprocal. Now, if you remember from chapter 1, One of our properties was that when we multiply a number and its reciprocal, we get 1. And that's why we're multiplying by the reciprocal in this case. What you notice is that you have 3 divided by 3, which is 1. You have 4 divided by 4, which is 1. And 1 times x is simply x. On the other side, 12 times 4 is 48, divided by 3 is 16. Or you might notice that 3 goes into 12 4 times, and 4 times 4 is 16. Either way, you should get the same answer. And checking our work, 12 is equal to 3/4 times 16. And double check to make sure that you do get 12 when you take 3/4 times 16. All right, so to sum up this problem, rather than divide, even though this is a multiplication problem and typically we would undo multiplication by dividing, since we are dividing by a fraction, we're going to turn that around and use our rule that we are multiplying by a reciprocal. So the reciprocal of 3/4 being 4/3, we're going to multiply both sides by 4/3, which eliminates our coefficient of 3/4. Okay, problem 6, using a one-step equation as a model. An online DVD rental company offers gift certificates that you can use to purchase rental plans. You have a gift certificate for $30. The plan you select costs $5 per month. How many months can you purchase with the gift certificate? The first thing I'm going to ask you to do as you solve equations is to define what your variable represents. In our question, how many months, we get our variable. So I'm going to choose M for the number of months. Now that I have my variable, I'm ready to write an equation. The plan costs $5 per month. 5 per month can be represented by 5 times M. The gift certificate that we have is for $30. So I want to know how many months that gift certificate can be used in order to rent DVDs. So here's a good equation to be used. 5M equals 30. To solve it, because we're taking 5 times M, which is multiplication, we're going to use the inverse operation and divide by 5. 5 divided by 5 is 1. 1 times M is M. And 30 divided by 5 is 6. And then every time that you have found your answer, you want to make sure that you label it in a real-life type problem. And since M represents months, we want to label our answer months. So our answer is 6 months. Now to check this out, you want to make sure that you have a reasonable answer. All right, so it says the plan costs $5 per month. And if I have it for 6 months, $5 times 6 months would be equal to 30, which is the amount of my gift certificate. Therefore, I have a reasonable answer. If you have any questions, please do not hesitate to bring those to class. Thank you very much.